Hey everyone, it's Chuck. I'm back again with my Space Station Pinball restoration project. Space Station uses a Williams System 11B board set, and the fuses are all over the place. There's a few here, there's some on this board here, and over here, and a bunch on the side, and there's some down underneath the playfield. What I'm going to do is pull out every fuse, and I'll probably just swing one end of the fuse out. I'll test that the fuse is good, and then I'll actually pull out the fuse and read that the current capacity of the fuse is the correct one for the position that it's in. I pulled the fuse out here. I've got my multimeter set to continuity check, which I'll show you if I touch them together. You can hear that noise, get the buzz tone. Here's the fuse. Let's see if I can do this with one hand. There we go. So you can tell that fuse is testing good. Here's a good example of why it's important to check your fuses before you power your new machine on. These two fuse holders here, F3 and F1, I pulled the fuses out and they tested good. But when I look at the fuses here, you'll see that they're both 5 amp fuses. Fuse holders F3 and F1, if I go over to my schematics here, F3 and F1 on the auxiliary power driver board, F1 and F3 through F6, they're all supposed to be 2 amp fuses, slow blows, and instead were 5 amp fuses, slow blows in there. So somebody probably just didn't have any 2s and they threw 5s in there and it worked okay because there was nothing wrong with the machine. But definitely good to swap those out, so I'll get those swapped out. In my last video, the auxiliary driver board was out of the machine. So I resoldered this relay, which when I got the game, the relay was desoldered from the board. I soldered it back in and I put the board back in. I turned the game on and ta-da, it comes up. It powers into a track mode. What I did then is drop the balls into the ball trough, and you can see the balls right here. Let's see if I can pick them over. Just gonna fire them back into the ball trough here. But when I dropped the balls down into the drain, they would just sit there, and there was a clicking sound from this relay up here that I showed you before. So the ball would just sit there, do nothing. It's supposed to fire over into the trough like that. Well, I tapped on this relay with a screwdriver handle. I just kind of tapped it a little bit, and sure enough, the ball fired into the ball trough. And in fact, all of the coils on the playfield would not fire until I sort of tapped on that relay. And the reason for that is that this relay switches between the flashers and the coils. The way the game is designed, there are driver transistors that drive. Each driver transistor can power 2 devices, and they switch back and forth between the 2 sets of devices using this relay here. So if that relay is out, you're basically going to get all flashers and no coils. So I took the relay apart, I just cut the top off with a Dremel, and just to confirm my suspicion, I cleaned or filed off the points inside the relay and put it back on the board, and now it works great. So I will be replacing that relay. I'm not just going to leave it as is. I wouldn't want to leave it without a top on it anyway. So I've ordered one of those, but for now, the machine actually starts a game and plays. As you can see, the ball came out. We'll fire it up and start a game. So now that I've got the game in a track mode, I started a game and I started playing with all of the playfield mechanics to see if anything else was wrong with the game. And I did find something rather important. A big part of Space Station is the ability to lock balls and start a multi-ball. And that requires this right here, the diverter, to work. And what this is a rotating piece of the playfield driven by a motor underneath, and there would normally be a Space Station model on top here, but I don't have that right now. But this piece underneath rotates and controls where the ball goes. You put it in different positions, it allows the ball to go into different parts of the playfield, into the various ball locks. So I'm going to start a game, and I'll show you what happens here. There we go. So ball 1. In order to get multi-ball on this machine, you have to knock down this drop target right here. And then you fire the ball up this ramp. Then it goes down that ramp and it falls into the first ball lock. So now the second ball is available. Let's grab that. Now what should have happened is this diverter should have rotated into the second position right there. And it didn't do it. But if it had, then we would have fired the ball up the ramp again, around here, and it would have gone into the second ball lock. Now we have 2 balls locked and the third ball's here. So now I have both balls locked, and in order to release them for multi-ball, I just put the ball up to the vertical up kicker here. See if I can get it up there. There it went. And there you go. It's going crazy. It's going to release all 3 balls. 1, 2, 3. This one coming up in the top. So this would have all worked fine had this diverter worked. So something is going on here. I need to remove this top and check out what's going on underneath. There are optical sensors that are underneath this piece that tell the position of the diverter, but the diverter's not even rotating, so that's the problem that we need to solve right now. So the ball diverter could be not working for a few reasons. The voltage to the motor could not be working, the motor itself could be failing, or there could be some type of computer logic problem that's not turning on the power to the motor. So we're going to test for one of these issues first, and that's that there is power coming to the motor when it's supposed to be turned on. So the way I'm going to test for that is, this is the motor here that drives the diverter, and it has a plug. It plugs it into the harness, and I've disconnected that plug and I put 2 alligator clip wires onto the wires that come from the CPU, and I clip those onto my leads for my tester. And I'm going to set my multi-tester to AC volts. In the manual, it says this motor runs on 24 volts AC. So I'm going to set my multimeter to 200 volt max AC. And then I'm going to set this down here where I can see it through the playfield door. And I'm going to close the playfield, and then I'm actually going to trigger the diverter event and see if we get voltage. Okay, I got the playfield down. I've got my multi-tester hooked up here. We're going to start a game. The ball will come into the shooter lane. I'm going to grab it, and I'm going to drop it into the diverter here, right here at the top of the diverter. It's going to flow down this ramp. It's going to go into the first ball lock. Once it goes into this first ball lock, this space station diverter is supposed to rotate. So as soon as I drop that ball in and it gets locked, you should see somewhere around 25 to 30 volts show up on this meter here if the board is sending the proper signal, sending voltage to the motor. If that's the case, we'll know that it's not the power to the motor, that the motor itself is probably the culprit. It's probably faulty. So let's go ahead and give it a shot. Start a game. Here's our ball. Grab it. I'm going to put the camera on the meter for you. Drop the ball in. And there, and right there, 30 volts. So the signal was just sent to the diverter to turn. Obviously I have it disconnected, but that means that when it was connected, it wasn't working. So that means the motor is suspect. So my plan here is to take this diverter off of the top of the motor spindle. And I want to check underneath it. There should be a board with some optical sensors that show the position of the diverter. So I tried to take this nut off the top of the diverter so I can get underneath and then get the motor out. Unfortunately, it's just spinning. It's a nylon lock nut, and when I turn it, the whole shaft spins, and I really can't find a place to hold this shaft still so I can get the nut off. I tried reaching underneath with needle nose. I tried jamming a screwdriver in the gears of the motor. It's all just slipping. So I need to take some time to figure out how to best get this off without destroying this plastic piece or any other parts. So I'll leave that for next time. Thanks for watching, and we'll see you soon.